If you start me up. Yes, today, look at this. We're looking at the start button. We've got some other different buttons. We've got an extra ball button. We've got an exit button. We've got a flipper button. These are kind of exciting. I mean, because everyone's seen these buttons on real machines. These are real buttons from real machines, but we're going to be using it on the virtual pin. So I'm going to be cutting the little holes to put these in. I'm not going to be doing any wiring. I'm just sort of putting them in and getting them ready. I'll talk to you about what buttons are, just based on what I've learned. But it's kind of cool, it's kind of exciting, so let's get started. So we have a traditional start button from a pinball machine. It's actually two things in one. You've got the actual button, and that button is controlled, or works a micro switch under here. You can sort of see when I push the button, it activates this micro switch. There's three terminals that come out of the micro switch. You only use two. Which two depends on the sort of the internal mechanism and how the button works, whether it's closed or open. But essentially, you've got two wires that come out of here. One wire is common, and it goes to the common on the board. The other one is sort of the signal. When I say signal, there's going to be a wire that goes from one of these terminals to my Pinscape board, and you can also see these numbers. So it goes to a specific number. Just for example, let's just say that this terminal goes to terminal number 1. So when this little board senses a signal into number 1, and in turn sends another signal to the computer to tell it to do something. In this case, it's the start button, so it's going to tell a game to start. Just kind of cool. Inside is a bulb, so you've got to be able to apply power to the bulb, and that's done on these two terminals on either side. So when there's a current, 6.3 volts, the bulb will light up. Some bulbs are lit all the time. Some bulbs are just lit occasionally. So again, the software, when you set it up, will tell the bulb to stay lit all the time or just to light on occasion. Sometimes the extra ball is one of those ones that's lit on occasion. It's only used a couple of times at the end of the game. I'm actually going to be using my extra ball button as the coin in button. So when the button is depressed, it's going to send a signal, and it may end up in number, whatever it is, don't quote me, number 3. Number 3 means, oh, a coin has been put in, which we know it's not. It just means my button has been pushed. Flipper button. So much fun, so much joy, and so much anguish. But flipper buttons are a little bit different. They're connected to, or they are part of what's called a leaf switch. So you've got the cabinet, you've got the button in the cabinet, and then what happens when the little thing depresses these two metal terminals, there's contact made. And then the two wires coming out of here, again, will go back to the Pinscape board, say for example number 5, and that says, oh, the left flipper has just been pushed in, so we need to move the flipper. On a real machine, the solenoid would fire, but in a virtual machine, obviously the flipper on the screen will fire. So that's called a leaf switch. You'll see it once I put it in, but it's kind of cool. I also have a green button. It's a exit button. You won't see these on a real machine, but on a software-driven machine, you need a button to escape, which is where it's mapped to. The escape button on your keyboard, it backs out of whatever you're doing. So if you're changing programs, changing games, you're going to push the exit button. So I'm using 3 buttons on my machine, and obviously the flippers. So let's go and drop them in. So I've got my little button ready to go. I'm going to put the exit one in first. You can sort of see where the decal went over the 3 holes. They've already been pre-drilled. I've got an X-Acto knife, which is I'm going to cut around the circle. So we're going to do a couple things first. We have to take off the switch and the bulb. So we're going to take that out. And then we're going to undo this. And then we're going to cut our hole. We're going to put that in and we'll screw it up. So let's go. Yeah, I had some trouble with the button because I didn't really know what to do in terms of cutting out the hole, because it's actually like a reset for the button. And as I was pushing it in, I didn't realize how far the button actually went in. So what I did, I took the button out and I trimmed all the way around here. I'm going to have to touch this up just with black. Again, these are little details, and honestly, it's just, I'm just worrying over just silly little things, but This is what keeps me awake at night. So I cut it completely out because the button actually goes and really, it completely recesses in. It's almost, it's not flush with that, but it's really quite deep in there. So I'm just going to use a black marker or black paintbrush just to clean it up a little bit, but I think that looks pretty good. So let's do the other ones. So I'm using this little X-Acto blade. Well, it's a big one. It doesn't actually fit on the one I have. I got the three buttons, the three holes cut out. You could see my little F up where the blade slipped and I cut it. It's just sheer stupidity, and things like that just drive me crazy. Stupid mistakes. I'm going to, as I said, touch up just so there's no white. I might use a little paintbrush. Again, from a distance, you're not going to know it, but I know it, and it drives me. It's just kills me. All right, so I've got the start button, extra ball, and my exit button. So they look amazing, but I just want to show you how they work in terms of the lighting. So let's go and have a look inside. So this is a test bed. So again, ignore the color of the wiring. I've got a 12-volt power supply. It powers this little, what's called a step-down converter. So it's taking 12 volts from here. It does its magic in there, and then output is 6.3. So I'm going to turn it on, and you're going to see that it reads 12.2 is coming in. If I push this little button here, it changes to 6.3. You probably, I don't know if, yeah, you can see it. You can change the voltage that's coming out by turning this little screw here. But I want to 6.3, so it's set up to 6.3. And then the blue wire and the black wire are going straight to the button. So we'll have a look at that. So the blue and the black wire connect to those little terminals on the side, and then we spin it around. Ah, it's lit. So that's so cool. Man, things like that just woohoo! Except for that stupid cut. All right, what's next? So that's the buttons cut out. These were a lot more forgiving. You can see this has like a lip which covers up any crappy cutting that I might have done. They were quite tough to get in, actually. I had to tap a little bit with a hammer. These guys here, done. I'm going to touch up the outside just so you don't see the white. But pretty cool. And I'll take you over to the other side. And on this side, I put the launch button in. Launch button. I've also got the plunger. They essentially do the same thing. Some games have a push button, whether it's a gun or whether it's some sort of target cannon thing you have to shoot. Obviously an old school plunger. And then the two buttons. I forgot to mention 2 buttons. The red one traditionally is the flipper. The white one in some games called a MagnaSave. Black Knight has one where it has like a magnet. It'll stop the ball. So it's only used in a couple of games. With a virtual pin, you can actually map these buttons to do other things, whether it's changing the volume of a game or anything else. So I just like the look, the two button look. I was really going for a traditional build of a Williams machine. And so that's what this cabinet is. So different manufacturers have different button configurations. So this is mine. This is what I wanted. So I'm really happy with the buttons. So they're in. It's another step. And then now we just have to keep on going.